Hello. In this video, we'll explore the fundamental definitions and rules of exponents, which are essential concepts in mathematics. First, let's define what an exponent or power is. An exponent tells you how many times to multiply a number, called the base, by itself. For example, 2 to the power of 3 means multiplying 2 by itself 3 times. In the general form, a raised to the power of n is called the base, and n is the exponent or power. Next, an exponential function is a function where the independent variable appears in the exponent. A common example is f of x equals 2 to the power of x. Now let's dive into the essential rules or laws that govern how we work with exponents. Rule 1, the product rule. When multiplying exponential expressions with the same base, you add the exponents. For instance, 2 squared times 2 cubed equals 2 to the power of 2 plus 3, which is 2 to the 5th. Rule 2, the quotient rule. When dividing exponential expressions with the same base, you subtract the exponents. Example, 3 to the 5th divided by 3 squared equals 3 to the power of 5 minus 2, or 3 cubed. Rule 3, the power rule. When raising an exponential expression to another power, you multiply the exponents. For example, 2 cubed raised to the power of 2 equals 2 to the power of 3 times 2, which is 2 to the 6th. Rule 4, power of a product. If a product is raised to a power, you can distribute the exponent to each factor in the product. Example, the quantity 2 times 3 squared equals 2 squared times 3 squared. Rule 5, power of a quotient. If a quotient is raised to a power, the exponent applies to both the numerator and the denominator. For example, the quantity 2 divided by 3 cubed equals 2 cubed divided by 3 cubed. Rule 6, the zero exponent rule. Any non-zero number raised to the power of 0 is equal to 1. For instance, 5 to the power of 0 equals 1. We can see this from the quotient rule. A to the n divided by a to the n is a to the n minus n, which is a to the 0. But any number divided by itself is 1. Rule 7, the negative exponent rule. A non-zero base raised to a negative exponent is equal to the reciprocal of the base raised to the positive exponent. Example, 2 to the power of negative 3 equals 1 divided by 2 to the power of 3. This also follows from the quotient rule. A to the 0 divided by a to the n equals a to the 0 minus n, or a to the negative n. Since a to the 0 is 1, this is 1 over a to the n. Rule 8, fractional exponents. An exponent of the form 1 over n represents the nth root of the base. An exponent of the form m over n represents the nth root of the base raised to the power of m. For example, 8 to the power of 1/3 is the cube root of 8, which is 2, and 4 to the power of 3/2 is the square root of 4 cubed, which is the square root of 64, or 8. Finally, let's touch on some properties of the exponential function f of x equals a to the x, assuming the base is positive. The function value is always positive. The function shows exponential growth when the base is greater than 1, and exponential decay when is between 0 and 1. All exponential functions of this form pass through the point 0, 1, because any positive base raised to the power of 0 is 1. Understanding these definitions and rules is crucial for working with exponential expressions and functions in algebra, calculus, and many scientific fields. Thanks for watching.